Hi, stats. We're going to go over 129 and 130. Let's go ahead and plug the data into Desmos first. And I'll just run through it all. So the first thing I'm going to hit the plus button, fill out a table, and plug your data in. So 78 and 485. Then you have 88, 534. And you got 94, 601. 83, 541. 66, 197. 101, 656. 92 and 600. 88 and 534. 90 and 587. And 80 and 478. Okay, so if you hit the plus button, there's where our data looks like. Then we're going to go on Desmos. We're going to go Y1, and then we're going to hit the tilde, which is on the alpha, MX1 plus B, and that gives us everything in our linear equation. So create a histogram. It's right there on Desmos. What's the explanatory variable? That's the X value, which is the high temperature. What is the response variable? That's the number of visitors, the Y value. Is there an association between high temperature, positive or negative? Okay, so what we're going to do is we are looking at our R value. It's positive. We also have a positive slope, so it's positive correlation. Okay? And you can say things as it goes to the right, it goes up, things like that. Is the association between visitors weak, moderate, or strong? Well, it's a 0.937, so that's like a 93.7%, so that's pretty strong. Okay, number 6, interpret the meaning of each statement. There is positive association between cholesterol and heart attack. So it means that you would have a slope that would be positive. Okay, there's a weak association, the positive association, it's going to be close to 1. There's a weak association between cholesterol level and heart attack risk. Weak association means that our R value would be close to 0. And then on page 130, what is the explanatory variable? That's the X value. That's eruption time in minutes. The response variable is the time between eruptions. Describe the association between Old Faithful time and time between eruptions. It seems to be a positive correlation. I don't think it's a very strong one, but it's a positive association because as we go to the right, it goes up. How well do you think a person can predict time between eruptions and eruption time? Being it's probably about 0.6 or 0.7, you'd be like 60 or 70% sure that it's going to erupt on time. And then just a guesstimate. And then let's plug that into our calculator. So let's clear that. Let's bring a table back in. Change that to Y2. X2. All right. So plug it in. So I'm going to get 4, 5, 4, 5, 6, 5, 7, 7, 4, 4, 5, 5, 2, 8, 8, 3, 7, 6, 5, 2. All right, so if I hit the plus button, that's basically what it looks like. So our R value is negative, so we have a negative slope. It's a pretty weak negative association is what you could say. Okay, so that should take care of the homework. Let's go to the assignment, or go to the lecture. I'm going to be on page 32. Okay, in statistics, so this is on page 32. So in statistics, correlation is simply a number that measure both the strength and the direction. So strength is close to 1 or -1. That means it's stronger. Positive or negative just talks about what the slope would be if the slope is positive or negative. Okay? Close to 0 is a weak association. Okay, a weak correlation. All right. So in statistics, the correlation, we've been talking about this, is the R value. Let's not worry about R squared right now. It's the R value. So the closer that is to 1 means really good. The closer it is to -1, really good data, okay, versus positive or negative. Positive linear means you're a positive correlation. Negative linear, it means you have a negative correlation. So as we go down on our sheet, they have an R value equal -1. This is a -1. So it's basically the straight line. Notice it's a negative slope. And then they say, hey, we have an R of -0.7. So it's kind of scattered all over the place, but you can see that it's going there. They have the rest on bottom page 32. Notice as it goes to this, we have an R equals +1. So those are things. So the correlation coefficient of 0 can play out a number of ways. In graphing below, provides scatter plots. Observe in ways that which the scatter plot might still have distinct patterns. Okay, there's all kinds of patterns. If you plotted your data and it started looking something like that, that's a pattern. If you started plotting your data and it looks like that, that's a pattern. This would be a pattern. It's when you have it all over the place and it just looks like you threw a whole bunch of mud against a wall, it just scatters, so there's no pattern. Okay, so you want to be looking for patterns that are in there. The one thing that we are thankful for that we have Desmos is this equation. This equation right here is the equation you would use, etc. I mean, this is a huge equation, but Desmos does the R very quickly. Okay, it's good stuff. So you need to know that when you're collecting stuff in the real world, you can have, messy data, convoluted data, scatter plots, such clear, distinct shapes don't occur. But in the exercises, depending upon the correlation aspects of scatter plots, they should measure. The bottom row of the display show nicely that 0 correlation doesn't always emerge as a random scatter of points. Correlation is a number and has no units of measure. As such, when you calculate the correlation between two variables, it doesn't matter what the units of measure are the variable uses. In other words, if you create a scatter plot of temperature and speed, you get the same correlations compared to Fahrenheit versus miles per hour. Okay, so your assignment can be on 2.2, which will be 131, 132. All. Cool. Have a great day.